Greetings, enthusiasts of the science realm. Welcome back to our space. Today we're taking a deep dive into the intriguing world of material science, specifically focusing on the determination of Young's modulus in a laboratory setting. So, buckle up for an enlightening journey into the elasticity and strength of materials. First things first, Young's modulus, named after the British scientist Thomas Young, is a numerical constant that describes the elasticity of a material. It's essentially a measure of how resistant a material is to being deformed when a force is applied to it. In layman's terms, it's all about how much a material will stretch or compress when subjected to a certain amount of force. Our experiment today will require a few things: a sample of the material we're testing, a ruler, a micrometer, and an instrument to apply force. The idea is to apply a known force to the material and measure the resulting deformation. This will allow us to calculate the stress, and remember, stress is simply the force applied divided by the area over which it's applied. Next, we measure the strain. Strain is the change in length of the material divided by its original length. To measure strain, we'll be using a micrometer, which allows for very precise measurements. Now here's where the magic happens. We take the stress and divide it by the strain. This gives us Young's modulus, so it's essentially a measure of the stress required to produce a given strain, a way of quantifying how the material responds to external forces. And just like that, we've determined Young's modulus. By understanding this property, we can derive valuable insights about the material's stiffness and how it might behave when subjected to different forces. In essence, Young's modulus is a key player in the realm of materials science. It provides a window into understanding the behavior of solids under stress, offers insights into material properties, and showcases the elegance of physics in a tangible way. If this exploration of Young's modulus sparked your curiosity, don't forget to tune in for more scientific adventures. We've got a world of material science topics waiting to be uncovered. Until our next rendezvous in the realm of science, keep your curiosity piqued and your mind open to the fascinating resilience and strength hidden within materials. Until then, keep exploring and see you at our next experimental adventure.